Welcome to the session about streamlining SAP workloads on Azure using openQA. My name is Kimmo Fors. I'm a principal engineering manager at Azure Core, working in the SAP on Azure team. I'm joined today with my friend and colleague Harry Sage from the SUSE QA engineering team. So the agenda today is we'll talk a bit about the background for our partnership. So Microsoft and SUSE has been working together for quite a long time. Then Harris will give you an open overview of openQA, after which I will talk to you about my baby in Azure, so the SAP Deployment Automation Framework, which is a product that I own. And from there, we will do a deeper dive and looking in at what actually openQA and SDAF integration can give you as a customer. And then we'll end up with a small Q&A that Harris and I will do. So as I mentioned, we've had a partnership between Microsoft and SUSE for quite a long time. The partnership between the SUSE QA, LSG QA team and our team is actually more new. We've been working together quite closely now for a little over a year. And the plan for the partnership is actually to make sure that we deliver a better experience to you, our customers who are using SUSE products when running SAP on Azure workloads. So we wanted to make sure that we have a robust kind of validation mechanism in place where we can not just validate like deployments with the current distributions, but have a better way to identify scenarios where there might be regressions introduced due to new distros or new utilities that are being patched. And also, we wanted to build a set of tooling that can more speedily allow us to test new OS distro versions. So upcoming distros can be more thoroughly tested before we release them to the marketplace. So with these, our goal is actually to, at the end of the day, increase the product quality and boost the collaboration between our two teams. So we both have. So I'm in charge of the SAP deployment automation. So we're actually combining these two. So we're combining the QA automation capabilities with our capabilities to actually deploy SAP on Azure workloads, so that we can really quickly identify if there's any issues. So this allows us to streamline the process so that we can run tests daily, so that we can be sure that we detect any regressions really early.
Thank you, Kimon. openQA is a SUSE QE tool written by SUSE folks for SUSE. It has a history for now over more than 10 years, created as a hack day tool for making sure our ISOs are installed correctly. In the meantime, we are able to use openQA for all kinds of tests, multi-machine, multi-architecture, and also cloud tests as well. openQA nowadays has a large majority of use cases, but nevertheless, the idea behind it is always the same. Simulate a system administrator, simulate a person behind the keyboard. We are open source, and as such, openQA is an open source tool. It doesn't touch the software at all, what is tested. It controls the keyboard and mouse. It uses in the backend OpenCV, which basically reads the actual screen output and compared the so-called needles on it to make sure that nothing is going wrong or as not proposed. There are a large number of tests written for openQA, and by that, there's a huge majority of the Linux distributions by now and open source project using openQA. In this case, we are using openQA to deploy and execute tests on Azure, and we have enabled SDAF to deploy SAP workloads on Azure. This is done by basically strip booting a virtual machine, which is then taking over a cloud instance, so-called deployer. The deployer is set up, and from the deployer, all the tasks which are known to you in SDAF are executed. Deploying the workload zone, deploying the SAP systems and environments, and also in this case, deploying the HANA SR. Then the tests are executed, we are collecting the results and doing the so-called cleanup. During the cleanup, we are making sure that all the artifacts are gathered and archived. And by that, I'm giving over to Kimo.
Thanks, Harris. So next, I wanted to give you a bit more of a deep dive of the SAP Deployment Automation Framework. It is actually a full life cycle solution that we've designed to deploy all of the various SAP on Azure estates. So meaning that we can deploy systems using like HANA systems, but we also support any DB on Oracle, on DB2, Sybase, etc. So the deployment utilizes Terraform templates to create the infrastructure, and then we use Ansible as the way to configure those the systems themselves and perform the installation. So the framework, in essence, has two main components. It has what we call the control plane, and then we have the workload zones and the systems. So the control plane is essentially the execution environment. So it is used to both deploy the SAP infrastructure using Terraform and to install SAP applications using Ansible. So it houses a number of virtual machines that can be used as deployment agents if you're running in a DevOps environment, or they can be used as controllers like what we're doing in the openQA case. So they will perform the Terraform deployments, and then from the output from the Terraform deployment, they will trigger off Ansible playbooks that can be used then to configure and install the SAP systems. The control plane also provides persistent storage for not just the Terraform state files, but also for the SAP media that we used to install the actual installations. We also are doing deployment securely, so where all the deployment credentials are always stored in a key vault, and the key vault permissions are very locked down, so that only the deployment credentials have access to the key vault to get the SSH keys, etc. So that is the kind of control plane, which is the engine for deployment. Then the next component is the workload zone, which essentially you can think of that as the shared infrastructure resources for the actual SAP deployments. So you can use the workload zone concept to partition your different environments into logical partitions like development, test, production, etc. So it provides the shared services for those environments. So networking, a, a key vault for the SAP system credentials and the virtual machine credentials, and also optional storage in case if you're using things like Azure NetApp files, etc. So an easy way to understand this would be to think of the workload zone acting as a swim lane for the workloads. So it creates a demarcation between each environment, uh, development, test, and production. So the benefits of doing it this way is that it allows us to create a very repeatable framework, and it follows very nicely the best practices that we have for doing infrastructure as service deployments on Azure. So we're following the well-architected framework, but on top of that, we're also making sure that we are building the systems using the latest Azure reference architectures. So we are deploying a resilient architecture with high availability options. So for HANA deployments, we can configure pacemaker and HANA system replications as part of our Ansible playbooks. As I mentioned, we do support various different operating systems. So primarily it's SUSE and Red Hat when using HANA, but we also support Oracle Linux, we support Windows, And the benefit here is that we can, regardless of which SAP and Azure flavor you use, it's the same orchestration. So it becomes very repetitive and a very easy to use process to deploy the systems. So also, all of the systems that we deploy are enterprise production ready, which means that we're protecting all of the storage accounts and key vaults with private endpoints. We're deploying storage accounts without access keys, etc. So we are locking down the systems in an enterprise level deployment by defaults. So SDAF, as I mentioned, it is open source, so it is maintained by my team, our team. We add features continuously. We do accept pull requests from customers and partners as well. So, and we have at the moment, we have a, a model where we're trying to do a release every 2 months for shipping new versions of that stuff. So it is very widely tested by not just the QA project now, but we have also customers and partners who are not just testing, but they're also extending it with their own modules.
Thank you, Kimo. Now, I would like to ask you, invite you to follow the deeper dive. The deeper dive here is mainly regarding how do we, from the QA side, execute our tests. Once the SDAF is successfully deployed and the SAP systems are in place, openQA is making sure that created and designed tests, which we basically created with our year-long experience, are executed on Azure. There's a deploy infrastructure sequence, there's a execute test sequence. The execute test sequence is starting by running the tests on the master or primary node, and the same that is then again executed on the secondary or slave node. So what we are doing there is breaking the system, more or less. We are making sure that the instances are gracefully and non-gracefully shut down by introducing errors on purpose, and by that, making sure that HA in this case is behaving as expected. There's a number of tests which are executed there, tests which are emulating the errors, but also tests which are basically making sure that the functions provided by the resource agents are in place and errorless. On this example here, we can see the test sequence on HANA SR, and some basic tests are executed. Once again, every executed test are archived and basically saved for later, so we can reproduce the state of this test. If we go deeper, we can see here the test sequence, graceful stop with HTTP stop. We can also do HTTP kill, and we can crash the system by introducing the proc sysrec commands. And there's an expected behavior there, which should follow automatically. Is it failed? Then the test failed. Is it did it pass? Then the test was okay. We are executing a huge majority of those and similar tests on Azure and also on-prem as well. The same sequence is then repeated on the secondary or on the slave node, and we are following the outputs of the tools on the console, which we can see here on the left side, and making sure that everything was done as expected. In case something goes wrong, openQA is giving us the opportunity to find the failed step quite easily, while highlighting the failed status in the web UI and also providing us with the needed information for debugging. In this case, we have a Python issue. So we detected the regression We know in which deployment step this happened. We have the console output, and as mentioned, the tests are archived. So it's quite easy and self-explanatory to find an issue which is targeted by this test. And by that, I would like to go furthermore into the day two operations. While finding issues on the deployment and the installation is our daily bread, basically, we are going here a step further with the day two operations and making sure the enterprise grade deployments, such as stuff is providing to the customers, are also tested by openQA and SUSE. So the idea here is to have the environment validation pre and post updates. We are also executing the migration preparation, patching to the latest level, for example. We have several scenarios for upgrade and for patch, and we are executing those scenarios as well. On the SAP side, Kimo, would you like to take over?
Yes, thanks, Harris. Yeah, so the way that we're looking at leveraging SDAF for day two operations are, since it's primarily focused on the deployment part, so scenarios like scaling up the environment, so meaning adding servers is a really common use case where we see SDF being leveraged not just to do the initial deployment, but also to grow the deployments. The other capability that we have, which is actually quite interesting, is actually moving from standalone to HA. So in many cases, customers have their primary environments configured as highly available, and then they have a disaster recovery environment, which is typically not always configured as highly available because the hope is that you wouldn't need to use your DR environment. However, if there is a serious outage on the primary side and you actually need to keep running from the DR environment, it is beneficial to be able to convert your standalone deployments to HA. So that's one of the capabilities that we have in SDAP. You can just essentially change two parameter files in your Terraform configuration, rerun the deployment, and it'll add the secondary nodes for the central services and also for the database. And then by running the Ansible playbooks, it'll configure them from being standalone to be highly available. So it's not a common use case, but it's actually quite a critical use case that we have. The other day two area that we've been focusing on is actually extensibility using our Ansible playbook. So we essentially have the ability to call pre and post playbooks as part of the task. So our Ansible playbooks today focus on doing the configuration required to actually being able to install the SAP application itself. However, there might be other system configuration activities that you want to do. So we have the ability to actually hook into the pipelines that are doing the deployment, so you can actually bring your own playbooks to actually add them into the orchestration of stuff to achieve the business goals that you want.
Thank you, Kimo. So it's worth mentioning that after SDAF executed day two operations, from the SUSE side, additional tests can be executed. Additional tests, which described beforehand, are pre-flight checks, migration preparation checks, and also making sure that the environment is in the state to take over or to execute the enterprise grade environment. So the day two operations on the openQA side are basically environment validations. We are executing the maintains. We are executing the zipper patch and zipper update. We are making sure that the network and the disk are in place and stable. We are executing so-called the pre-flight checks for the HA stack, but also on the system as well. And we are running the maintain tasks, which is the single package update or a bundle update of the whole patterns. This is all done in openQA, and the user or the admin or the QA DevOps engineer can follow all the screens in the web UI of openQA. The regression prevention is this case is the upgrade scenarios and the patch scenarios. So we have the rolling update, which is where the tests are making sure that obviously the system is patched to the latest level, the test is executed, everything went fine. But there's also a service spec update. And with the service spec update, this is where the customer are considering going to a higher level service spec on the SUSE side. Making sure that all the tasks are prepared and fully tested before the customer is executing this in the production. The patch scenario is mainly focusing on a bug fixing. So what we have is our so-called maintenance updates, where one or several packages are updated. This could be security related, or it could be functional related when something some error is detected on our side, and then these packages could be highly crucial for the runtime, and we are basically making sure that this kind of packages or this kind of updates are not breaking the running environment, the production. It's known to us, for example, that some upstream projects have changed the structure of the RC file, and by that, the whole landscape of customers' production was affected because it slipped through several instances. And if we do those tests on Azure in the pre-production, we are basically guaranteeing those kind of issues will not happen. Although we all know security and quality assurance is a way how you how you consider and take care of your environment. It's not a state. I mean, everyone makes errors. The maintenance tasks are single package versus bundle updates. Once again, the package is in the production. We find an error, we fix it, and we make sure that is no regression on that side by executing the variety of tests in the pre-production or the QA environment provided. Regression is we take regressions very seriously. So we know that a smallest regression, like in the example mentioned before, the whole production can fail because of the RC file. So in the SUSE QA, we developed a test called sysparam check, which is executed once. At the beginning, once we know that the infrastructure is stable, we basically make sure that all the values are saved, and we compare in the following updates and following runs against those values. We have the installation validation on the package level. So this is done obviously at SUSE side before delivering packages and maintenance updates. But also we are repeating those tests in a production as well, or in the cloud as well, depending on the setup. And by that, I would like to thank you for listening, and looking forward for your questions and answers in the proactive round. Thank you.
Thank you.